and welcome to today's webinar, Start Smart, Essential Safety and Operational Practices for Ammonia Refrigeration Professionals. My name is Vanessa Heathcock, and I'm the event manager at refindustry.com, which is short for Refrigeration Industry. For those who may not know us, Refindustry is an online platform created specifically for refrigeration and RCHP industry professionals worldwide. It's your go-to resource to stay informed, connected, and ahead in your field. So before we dive in, let's warm up the chat a little and check our connection. So please put pluses if you can hear and see me well. We're waiting for participants to join us today. I think there will probably be a little lag between me and the chat, but I'm waiting for people to write. Please drop a plus if you can hear and see us well. I can see people joining. All right, I can see some reactions. I guess that means that people can hear us, I hope. All right, the first plus, we've got it. And while we're waiting for participants to join us, please type where you're joining from today, be it your country, your city, or even just your company. It's always exciting to see how global our audience is. So where are you joining from today? Please let us know. We'd like to get to know you a little more. So I'm just looking at Mexico. All right. I can see people typing. This is exciting. India, Kenya. Wow. All right. So please write where you're joining from. It can be your country, your city, your company. England, Colombia. All right. Malaysia. Amazing. Yeah. Fantastic. It's great to see participants from all over the world. All right. Thanks a lot for sharing. Oh, Ecuador, I can also see. Amazing. Thanks a lot for sharing. So today's session is on why the first 90 days in ammonia refrigeration systems are critical and how to set up your operations for success. We're very pleased to have Kushal Aurangabadkar with us. Kushal is the author of the article, The First 90 Days in Ammonia Refrigeration Systems, on our website, refindustry.com. So he's an experienced engineering manager specializing in ammonia refrigeration and process safety management with over 12 years of industry expertise. He's also a certified process safety professional and actively contributes to the IIAR and RETA. So Kushal, welcome. To start with, could you please tell us where you're working now and what you're currently in charge of? So what's your main focus at the moment?
Absolutely. Thanks for the invitation. So welcome everybody. I'm Kushal Aurangabadkar. I'm the engineering manager here at Cargill, one of the facilities in Texas. I'm working as an engineering manager. I oversee pretty much all the day-to-day maintenance, ammonia refrigeration system, utilities around it, and the project engineering side of things. So I've been with Cargill close to 8.5 years and a total of industrial experience of 14 plus years. So
amazing. Yeah, amazing. Thanks for sharing.
Thank you.
So I'll give a short outline how this webinar is going to run today. So we'll kickstart with a 40-minute presentation by Kushal, maybe a little more, but should be around that time. It will be followed with a live QA session. So we encourage you to post your questions in the QA section, because in the flow of the chat, we might miss some questions. We're going to read the chat as well, but please try to put your questions in the QA section. And throughout the presentation, we will have 3 interactive polls to engage everyone along the way and just to get to know the audience a little more. And yeah, let's jump into it straight away. So we're going to have our first poll. Just give me a second to launch it. You will be able to see it on your screen. Give me a second. So I'm launching the poll right now. So you should be able to see the poll, and please choose an option that suits you best. So take a moment to select an option. We'll share the results in a few seconds. All right, yeah, I can see the results. So at the moment, I can see that predominantly it's engineers/designers. There are also quite a lot of manufacturers/contractors. All right, yeah, great. Thanks a lot for taking this poll. So we know who is joining us today, who we're having. All right, so let's dive into the main presentation. Kushal, the floor is yours.
Absolutely. Thank you so much, Vanessa. So thanks for having me here. And my topic for today's webinar is essential safety and operational practices for ammonia refrigeration professionals. All right, so our top three objectives for today's presentations are as follows. Objective number one is we want you to develop and understand the key focus areas for an individual who is new to ammonia refrigeration. Objective number two is we want you to develop a high-level understanding of the risk-based process safety, and we're going to talk about the 14 elements of the PSM program as well. Objective number three is understanding the influence of the key stakeholders and the impact of maintenance around the ammonia refrigeration system on compliance, risks, system reliability, and overall PSM metrics. And we're going to close this presentation with a reviewing of two industrial case studies by implementing our learnings throughout the presentation. So jumping right in, the first topic we're going to talk about is the first 90 days in the ammonia refrigeration industry. That goes to my article that I published online on the website. I mean, as we all know, it could be overwhelming for an individual who is new to ammonia refrigeration industry. The first 90 days could really make or break an individual's career into ammonia refrigeration world. And it can be overwhelming. So what should be our focus? What do we really expect from an individual or a refrigeration tech who is new to the ammonia world? We want them to learn by shadowing our seasoned mechanics or techs on our team, absorb the work environment, and learn the job duties and not be afraid to ask any questions. So basically, every question they ask is what helps them learn the system, identify the hazards working around them, and our primary focus should be really developing a good understanding of the ammonia refrigeration system, process safety, and basically get some hands-on experience performing tasks under supervision. So as I mentioned, the first 90 days are very, very critical in terms of what we learn and how we grow. We divided the first 90 days into three different phases. Phase one being building the foundation. So we'll really build the foundation, what it takes to be a successful ammonia refrigeration tech. Our primary focus should be on safety, awareness, and observations. So it should really start with the ammonia awareness and safety training, as you see on the slide, which really includes the understanding the properties of the ammonia, exposure of the risks involved with ammonia, the PPE required while working on the system, emergency response procedures, evacuation routes, introduction to OSHA's PSM program, EPA's RMP, and basically IIR standards. That's what drive the standard of the industry. The second one on the list is familiarizing yourself with the site and the ammonia system. So walkthrough of the systems with the site of the ammonia system with the senior mechanics, learning functionality of the main equipment such as compressors, evaporators, condensers, vessel, pumps, etc. And understanding the piping codes, color coding involved at the site and the labeling that's involved on the ammonia pipes. And having a basic understanding what it takes, what's happening inside the pipes. And basic hands-on tasks under supervision. Basically, that entails your logging your pressure logs or temperatures and oil levels, and performing basic rounds in your engine rooms or control rooms, and shadowing your seasoned mechanics during the startups and shutdowns. So phase two, it's all about developing competencies, and we do this by hands-on learning and routine work activities. Our primary focus should be, and during this phase, our primary focus should be on developing confidence with the system operation and maintenance basics. So hands-on maintenance activities includes such as your oil draining activities, getting to know where your draining points, what's your lowest draining point in the system, your lubrication and seal checks on the pumps, hands-on activities with purging and defrost cycles. But that's all under supervision since we are still new to the system. Next one is to focus on interpreting the documentation such as P&IDs and SOPs to develop a better understanding of the system. Daily operations, one should focus on independently completing the log sheets and monitoring rounds, recognizing abnormal readings such as high discharge pressures and low pressure in the system. Troubleshooting exposure, one should really start learning about the common issues and how to recognize early signs such as frosting, uh, any abnormal noises or vibrations in the compressor motors, and assist in minor troubleshooting with guidance. Documentation plays a key role as one should really start to learn how to really document work orders in the centralized maintenance management system. And also communicate between shifts. That's another communication tool that one should learn during this phase between shifts. And phase 3 is about building independence. One should really focus on learning advanced operations, such as pumping down the system, applying knowledge, taking ownership of the routine tasks, housekeeping, developing deeper system understanding, and be a part of the hazmat team, and so on and so forth. So in this slide, what you're seeing here is a comprehensive guide for maintenance ammonia refrigeration system. So using this guide, we can basically help us segregate our inspection or equipment activities, maintenance activities into daily, weekly, monthly, quarterly, biannual, and annual tasks. This is not the extensive list by any means, but this is something we all can relate to as an industry into common terms. Daily tasks could be your daily system walkthroughs, just checking day-to-day operations and monitoring system operating parameters, housekeeping activities, and maintaining daily logbook. Weekly tasks could include your lubrication on any moving parts, monitoring ambient conditions to be able to operate the system effectively, depending on the condenser, the dew point, water treatment testing for the boilers and condensers. Monthly tasks could include your system, all draining activities on the system, work on ammonia pump maintenance activities. Quarterly tasks could include your inspecting condensers for scale buildup or identifying opportunities around piping insulation repairs or missing valve tags up on the roof. Biannual tasks could include your annual sensor calibration, so on and so forth. An annual task basically would be around your interim shunt trips or safety cutout testing, or any major overhaul around your ammonia compressors, so on and so forth. So switching gears, going from the ammonia refrigeration technicalities into the PSM world. So PSM stands for Process Safety Management. They go hand in hand. If you're talking about ammonia refrigeration, you got to talk about the process safety around it. So talking about how to identify the key stakeholders that help us build, maintain, and grow our PSM program. Basically, there are two types, internal and external. So in this slide, we're going to talk about what are the critical factors that help us identify these stakeholders. But before we get into that, I really want to talk about and highlight the three characteristics of the stakeholders that are pretty much power, legitimacy, and urgency. So having a good understanding, power is what it takes to control the resources, legitimacy to drive the process safety culture within the organization, and urgency is to drive the sense of response time. So going through the list, first is understanding the organizational structure. Understand the roles and responsibilities of an individual or a group of individuals that leads us into the next one, which is the interests and influence of the PSM program. Next is evaluating stakeholders' impact on or by the PSM program. Not everybody in the facility is getting impacted or can influence the PSM program at the same level. So having that good understanding of each and every stakeholder and their impact on the PSM program is a key factor. And it could be across all levels and cross-functional departments. Engagement and communication, it's a key within the organization. It helps us set clear directions and set expectations and hold. That is what helps us or enables us to hold people accountable and meet expectations. Next is regulatory and compliance requirements, which is what drives our industry standards and requirements such as IIR, OSHA, AAR. Resource and expertise. These are your subject matter experts, SMEs within your organization, such as reliability, structural integrity, food safety, environmental safety, etc. That helps us make fact-based decisions. So what are the common challenges to overcome? We're going to go through this and I'm going to shed some light on each one of these. So lack of awareness and understanding of the stakeholders. If you really don't have a good understanding of the roles and responsibilities of these individuals, you cannot fill in the gaps. So limited engagement from the senior management, it's a big one because senior management has the power to align the resources and manage budgets. Overcoming resistance to change, it goes back to the process safety culture, which is very, very key part, having a right culture in place and workforce involvement, because together they go a long ways in terms of successfully PSM implementation and delivering results. Developing trust and integrity. Trust is the basis of the process safety culture. Majority of the core principles of the process safety culture cannot even function without trust. Difficulty in prioritizing stakeholders, insufficient training and competency development, lack of data-driven decision making. A lot of what we do in PSM or risk-based process safety is managing the hazard, developing a plan to address the hazard, and that is only possible if we have a good documentation or management system in place that would help us make fact-based decisions. So why does it all matter? Why do these stakeholders matter when we talk about the process safety management or the risk-based process safety within our organization? Because stakeholders are the ones who help us drive organizational priorities and they help us allocate resources. They're the ones who have all the critical knowledge that we need to identify a hazard and come up with a control measure. And that they're the ones who can help us streamline and communicate the information throughout the organization at all across all levels. So as we talked about, the stakeholders, they are internal and external for the majority of the part. So internal stakeholders could be anybody from the top management down to your frontline employees and everybody in between. So it includes your facility manager, plant engineer, your key stakeholders from other departments such as food safety, health safety, and your frontline employees. Your external stakeholders are your emergency response team or community outreach representatives, or your regulatory bodies such as IAR. And your SMEs are no different than your PSM consultants or technology providers, so on and so forth. So the next slide we're going to jump in is risk-based process safety. So here we're going to talk about the 4 key parts of the CCPS framework. Commitment to process safety, understanding hazards. So there are 4 basic pillars. The first one is commitment to process safety on the bottom. Next one to it is understanding hazards and evaluating risks, managing the risk and learning from experience. So there are various elements in these key pieces of pillars. Commitment to process safety has 5, understanding hazards and risk has 2, managing risk has 9 elements, and learning from experience has 4. So just looking at this list, one can say that managing risk is probably one of the most demanding of all, as it has 9 elements. But I would say everything's demanding. It's all relative within your organization. Learning from experience is important too, as it forms a part of the continuous improvement loop. And finally, the house picture. Many of us would be familiar with this picture where the pillars are depicted forming the house diagram. So the bottom line is the foundation formed of the 4 pillars, which is commitment to process safety, understanding hazard and risk, managing risk, and learning from experience, followed by the vertical pillars representing all the elements that puts the roof on top, which is part of the PSM program. So what is a process safety culture? this is a good representation is what I came up with. So culture is a combination of values and beliefs within an organization. What we believe and what we value as an organization is really what drives the process safety culture. So in short, process safety culture is what drives the process safety behavior of an employee. So management system, the organization structure, leadership, and the available resources for an employee is what supports an employee's process safety behavior. So what is process safety performance or strong process safety performance? So when you combine a strong process safety culture with a solid management system, the end result, what you get is a strong process safety performance. So what constitutes of a strong process safety culture? And on the left, you can see that all these characteristics of a strong process safety culture, which is a leadership commitment. The leadership commitment must demonstrate and genuinely commit to process safety by allocating resources and the capital required to mitigate any hazards. Employee engagement, engaging employees at all levels and developing process safety initiatives, encouraging employees to be part of these initiatives of safety committees, PHA meetings, and training sessions, and they play a vital role in building a strong process safety culture. Understanding vulnerabilities, discussing key PHA scenarios or past incident activities or incident investigations at the site or industry-wide, and not just get complacent with the compliance metrics is what drives a strong process safety culture. Compliance with standards, we need to make sure we comply with the safety standards. Open direct communication, need to make sure every voice gets heard. Need to have open and transparent communication channels where employees feel safe, raising their voices around process safety, near misses, and other opportunities. Learning from mistakes. So we need to establish a robust incident investigation process to thoroughly analyze root cause of an incident or a near miss. And last but not the least is timely performing assessments. We need to perform our audits and inspections as required. So the next one we're going to talk about is a management system. It's nothing but a structured approach to identify, evaluate, and control hazards associated with handling hazardous chemicals. So we're going to deep dive into these elements into the coming slides. So what are the indicators of a failing process safety culture? First, we often see a surface level audit driven mindset, which is just check the box mindset. These audits focus on paperwork and less of an actual implementation or effectiveness of the safety programs. And this is what leads to a false sense of compliance. Second, there is an insufficient process safety leadership across organizational levels. I mean, leadership must model the importance of safety. And when this is lacking, this message gets lost throughout the system or the organization. Third, there's often a failure to address the process safety concerns timely and in a prioritized manner. This results in a growing backlog of the unresolved action items, and sometimes they are not even evaluated based on the risks, and which could lead to a big blind spot and big hazardous situations. Another serious issue is inadequate incident reporting and risk assessment practices. When lessons are not captured and shared, the same mistakes are repeated, and that's not the smartest thing to do. Gradual decline in performance standards is another key sign, often due to what we call normalization of deviance. Over time, tolerance for non-compliance increases, and what was considered once acceptable becomes the norm. Basically, we give in as time goes on. Persistent cost cutting and production pressures can seriously compromise decision-making ability to mitigate any risks. Limited awareness of the operational safety risks among senior management, including board members. When the top leadership fully does not understand the risks, it cannot provide the adequate oversight or support that's needed to mitigate the risks, identified risks. And finally, the poor housekeeping, which is evident by the frequent leaks, spills, and is visible and a telling indicator of a deeper cultural issue within an organization at all levels. Clean, orderly operations really reflect a strong process safety value. So here we're going to talk about the key principles that help us build and maintain the strong process safety culture. And we've already discussed some of these key principles in the previous slides, but I'm gonna highlight some of those that stand out. The first one is establishing an imperative for process safety, setting high standards, put process safety first, making sure we walk the talk, understanding and act upon the hazards. So we, as part of the PHA audits, compliance audit, or mechanical integrity audit, we identify all these hazards. But if we do not act upon the hazards and mitigate these risks, I mean, that's not going to help us build a strong process safety culture. So we really need to develop a culture to understand and develop a plan to act upon these hazards. Maintain a sense of vulnerability. As we talked before, we got to constantly review the past site incidences and industry incidences to get better and not repeat the mistakes over and over. Normalization of deviance, we talked about that too. So basically, when we give in, it can happen when people just get used to deviating from the rules and immediate consequences never occur. That's when these normalization of deviance sets in. Learn to assess and advance the culture. Ensure the process safety stories are being told within the organization at all levels to help maintain the sense of vulnerability. Make sure you are certain and everyone else is certain about the incident warning signs in your system. Acknowledge the team when they deliver on completing the managing the risk effectively and on time. These small recognitions really help and build a strong process safety culture. So here are the top 10 lists of the leading metrics. So I'm going to spend a little time to go through each one of these and kind of talk about what they track and why are they important to our industry. So these are the top focus of our leading metrics, which are the proactive indicators that help us build and measure our success and process safety initiatives before the incident occurs. As we know, progress can only be made if progress is measured. Simple as that. And here are the top 10 metrics. So the first one is number of past due audit action items. This shows whether we are following through or on our identified gaps from audits. A rising count on this metrics indicates a failing or a breakdown in our follow-up system. Number of past due PHA action items. Process hazard analysis often highlight critical safety concerns. Delays in addressing these concerns could increase the risk exposure. Number of outstanding incident investigations, action items closed. This metrics really tracks whether we are learning from the incidents and near misses by closing out our corrective actions. Activation of the pressure relief devices not counted as a process safety instances. So frequent pressure relief device activation can really indicate the abnormal operations or something wrong with the control systems or control issues, even if they don't result in a reportable process safety incident. This indicates underreporting. Demands on safety systems. This includes uh, activation of the emergency shutdowns or interlocks. It's a strong indicator that the process has moved outside of its safe operating envelope. Timely inspection of the safety critical items or devices. This ensures that the inspections of valves, relief devices, and other critical components or equipment are completed during the designated time. I mean, delays in these timely inspections can compromise protection layers that's required to keep our system and employees safe. Training for the PSM critical positions. Are we really ensuring that the operators, technicians, and our engineers that work on our safety critical roles are up to date on their trainings requirements, such as training on MOCs, PHAs, or hazmat, hot work, so on and so forth. Procedures are current and accurate. Procedures must reflect accurate operations. We need to ensure that all the procedures that we use to normally operate our system are current and accurate. And we need to annually review these procedures and make modifications or update these procedures as required. Activation of the safety instrumented systems. Procedures must reflect often actual operations. Activation of the safety instrumented systems. Frequent activation of these instrumented systems may point to degraded process controls and process control stability. And last but not the least is safe operating limit excursions. This tracks instances where the process parameters go beyond the safe operating limits. These excursions are early warning signs of the potential hazards. By routinely monitoring these leading indicators, organizations can really maintain a stronger, more resilient safety culture, preventing incidents before they occur. Vanessa, would you like to go in and kick in the poll question, please?
Yeah, I think we have had our polls. We already launched both of them, so.
Oh, you did? Perfect. Thanks for that.
Yeah,
Appreciate that.
It's all right.
So the next one we're going to talk about is the first pillar that builds their strong process safety overall. The first is understanding hazards and risks. So it really comprises of the two elements, process knowledge management and hazard identification and risk analysis. So process knowledge management really correlates with the process safety information element of the PSN program. It includes a documentation of all the chemical hazards, process technology information, and process equipment information. Process technology information, just to give you some highlights, is it could be your block flow diagrams or mass energy balance, maximum intended inventory, so on and so forth. Whereas process equipment information could be your materials of construction, relief piping design, safety cutouts, ventilation designs, or PNIDs. Hazard identification and risk analysis really encompasses of the activities involved in identifying hazards and evaluating risks throughout the facility. It typically follows a risk metrics, which is based off the hazards, the consequences, and the likelihood of it happening. And to get some of this information for the process equipment information, the UNA forms, which is the manufacturer's data report, is a really good starting point where you can get all the information about the equipment or the asset. So next one we're going to talk about is managing risk. So it mainly focuses on three issues. First one is it helps us ensure that we safely operate and maintain our process that pose risks. Secondly, it helps us manage any changes to the system effectively without any negligence. And thirdly, in simple, it helps us prepare and respond to any uncertain situations. No matter what precautions you take, and there are chances that the incidents might happen. And this really helps us build and help us maintain that potential to respond to any unseen incidences. In this slide, it really highlights the three core elements of a robust process safety management system, especially critical in ammonia refrigeration operations. First one is operating procedures, mechanical integrity, and training. So starting with the operating procedures, these are detailed written instructions that guide the operators during the startup, shutdown, emergency conditions, temporary operations. And they also clearly define the operating limit, the consequence of deviations when something goes outside of the operating envelope. And also helps with steps. It also guides through the steps to take actions or what to take actions when deviations occur. Without these procedures, really consistency and safety are left to chance. I mean, especially during off-normal situations when things are not going as per or ask. Next is mechanical integrity. It really focuses on preventing equipment-related failures that could lead to catastrophic releases. It really includes the routine maintenance activities. It walks out a plan and inspection and testing frequency for these maintenance activities. So it gives you a pretty detailed uh, plan how to take care of your assets effectively on a periodic frequency. Basically, the goal is to ensure the reliability of the critical components, especially when they're tied to the pressure relief and safety systems. And it's not about just maintaining the uptime, but it's about maintaining the safe uptime. So, and lastly, training. It's not negotiable. It's not an option. It's a mandatory pillar of safety. All employees and contractors involved in the ammonia refrigeration system or working on the system must receive proper training. Like I said, it's not an option, it's a mandatory requirement. This training must cover the process hazards working around and nearby on the system, the emergency response procedures and operating procedures, and safe work practices. And this can be covered through a lot of going through the contractor safety work with the contractors too. Crucially, trainings must be completed before the personnel are authorized to work on the system or the covered processes. So training is just not the box to check in. It really needs to perform and check and make sure that the individual is fully trained and capable to perform a associated task. When you combine these three pillars of operating procedures, mechanical integrity, and the training, it really forms the operational core of a safe and effective ammonia refrigeration system. So this slide really focuses on the four important elements that ensure the safe execution and operation of the ammonia refrigeration system. Contractors are really critical, as we mentioned. They are no different than our employees. When it comes to contractors, they should be fully and trained at the same level as our own employees. Pre-start of safety reviews or PSSR. This is the final quality gate check before the live operations begin after a major shutdown or upgrade to the system. Operational readiness. It ensures, it also goes when we talk about the risk-based process safety, it also is referred to as operational readiness. It ensures that the non-operating processes are verified to be in safe condition before they start up. This review ensures that the system is built as we designed for, as it was designed for. All the procedures are in place, the PHAs are complete, everybody working on the system is trained, and there's no gaps identified as far as the design and the reality of the project. Next on the list is a hot work. So it includes any activities, including welding, cutting, grinding, brazing, etc. I mean, these activities can ignite the flammable materials or release hazardous vapor in an enclosed environment. That is why we need a formal hot work program in place. So really, the goal for this program is to ensure that an activity that starts as a maintenance activity does not end in a fire or explosion. So before we start an activity that involves hot work, we fill this permit and we ensure that there's no hazards around, and if there are, we take care of the precautionary measures to mitigate the hazards. MOC is it's a system to ensure that the equipment in process put in place or any changes in operation that we make don't get changed without any going through a formal review or understanding the implications of the change. Together, these pillars like contractor, process safe, PSSR, hot work, and MOC, they act as safeguards at critical control points in the life cycle of a process. Ignoring any of these can lead to a gap with serious consequences. Emergency management, it really helps us plan for possible emergencies by practicing and improvising the plan and training with the key stakeholders. It's important because the consequences of any particular incident can be significantly reduced with the effective emergency planning and response in place. And we're going to review this particular emergency management piece in one of our case studies here in next coming slides. All right. This slide emphasizes one of the core principles of the process safety management, which is learning from experience. Despite all controls in place, incidences or near misses or deviation can still occur. The key is how we respond and adapt. So the first bullet point is correct deficiencies revealed by internal incidences or near misses. So how do we learn? So we must treat every near miss as an early warning sign and not just as an early or lucky escape. Each near miss or incident reveals a gap in procedure, training, design, or human behavior. And we need to work on closing that gap. That's what it all boils down to, learning from experience. Apply lessons learned from other organizations. We don't need to touch the fire to know it burns. I mean, we can learn from the incidents from the industry or the past case studies at the site. We need to get better. We don't need to repeat the mistakes over and over. Use metrics to evaluate the risk-based process safety effectiveness. Risk-based process safety systems should be measurable. Like we said, we need to have some solid quantifiable indicators that tells us how we stand as far as the risk-based process safety effectiveness. Turn mistakes into opportunities. It's all about mindset. It's instead of blaming, we need to choose growth. Every deviation is a chance to grow, re-examine assumption, improve processes, procedures, training, and ultimately elevate our process safety culture. In conclusion, learning from experience isn't just a best practice, it's an essential practice. It's how we evolve, improve, and prevent reoccurrence. So pretty much, here are the two case studies what we're going to talk about. The first, and we're going to close this presentation. So the first case study is we're going to talk about is the worst industrial accidents that occurred related to ammonia that occurred in Dakar, Senegal in 1992 at a peanut oil processing facility. This incident was also named as a cloud of the death in the local newspaper based on my research. So as the name suggests, a facility pretty much extracted oil from the peanuts, and some of the oil extraction process, ammonia was used to detoxify the peanuts before peanut oil extraction process. And ammonia was stored in a portable tank that was commissioned in 1983. So anhydrous ammonia was brought to the facility daily by the road truck from a nearby facility, fertilizer plant. The tank was then placed at the facility for use as a storage vessel. And I think we all know that's a red flag. Between 1983 and 1991, the tank was overfilled frequently, which led to the stress cracks on the surface of the tank. These cracks were detected in 1991 during the maintenance inspection, and they were repaired by the maintenance team, local maintenance team. That's another red flag. On the day of accident, the tank was overfilled and placed at the facility for use. March 24, 1992, around 2 p.m., the tank burst open and released liquid ammonia from the tank. During this event, it damaged the nearby hoses, which causing the discharge to continue for another 30 minutes. And pretty much a dense ammonia cloud settled over the facility, nearby offices, and restaurants. So in total, the incident caused 129 fatalities and over 100 or 1,100 injuries. And here in the bottom, you can see two pictures where the tank is ruptured in half, damaging the nearby structural buildings and the damage around. So doing a root cause analysis of the incident, it really revealed the primary cause as overfilling of the ammonia tank beyond its allowed capacity. In addition to the primary cause, there are several secondary causes that contributed to the failure. I mean, nearly after 30 years of the incident, it's nearly impossible to construct all the details based on the limited data available. But however, I mean, just going through the reports, available reports online, there are certain secondary causes that could be identified as they relate to technology, operations, leadership, and governance. Potential factors that contributed to the technical failure were poor understanding of hazards, of anhydrous ammonia under pressure, improper design of the equipment and utilization of the equipment and protection systems. So as I mentioned before, the storage tank was used as a usage tank. It was not designed to do that. Inadequate or no hazard reviews or lack of risk analysis. There were no risk PHAs performed that were listed. Factors contributing to the operations failure were related to the lack of training, poor emergency response planning, improper testing and inspection of the control systems and the equipment around, and potential consequences of the abnormal situations. Factors contributing to the leadership failure were related to lack of process safety culture at all levels, including leadership. There's no policies in place and no operating procedures or one-off procedures in place that would guide the process safety behavior within the organization. There was no sense of vulnerability whatsoever. And lastly, factors contributing to the regulatory governance were related to the lack of poor zoning of land use. And some of the PHA tools predicted a fatality rate of around 700 people, but just luckily the incident when this happened was a day of Ramadan and it was a national holiday. So nearby offices and schools were closed. And that is what really, in a way, fortunately helped that number to 129 fatalities. Poor emergency management and community reach. There was no communication whatsoever with the local community folks about the incident. Poor implementation of safety audits. There was no signs of any soft safety audits were performed prior to the incident. All right, so the main learnings from the accident highlight the need to ensure an understanding of the hazards around ammonia under pressure, design fail-safe equipment and ensure appropriate utilization in processes and transportation, train operators and emergency responders, and conduct frequent risk hazard analysis and risk assessments. I mean, having all these in place could definitely help us mitigate and avoid incident what happened here. And in conclusion, really, it's essential to continue to develop and implement process safety standards for safe design and operations of the equipment. Also to focus on process safety culture at all levels of an organization, no matter what level we're talking about. And have a regulatory and compliance governance by implementing the risk hazard analysis tools and assessments in place and following and having a solid follow-up process to work on the recommendations identified. It's never too late to learn from the past experiences and correct our processes. So I'm sure we can take this one incident and learn a lot and make sure we can find the gaps in our own systems and avoid a similar situation. So the second case study we're going to talk about is about the heat exchanger failure at the Goodyear facility. So on June 11, 2008, the Goodyear facility experienced a catastrophic event at their facility. They left 6 injured and 1 person dead. On June 10th, just giving you a brief about the incident, what happened on June 10th, 2009, the day before the accident, the operators needed to change a rupture disc that was leaking. So the operators closed an isolation valve between the heat exchanger and the relief valve that provided the overpressure protection. Maintenance workers goes in and change the rupture disc on June 10th, right before the second shift ended. but they did not open the isolation valve as they were supposed to. Maintenance also did not tell the operators that they were finished and there's no lockout tagout performed. On the morning of June 11th, an operator needed to clean this piping with steam as a CIP, so he closed the block valve, isolating the ammonia pressure control valve from the heat exchanger. And basically, steam flowed through the heat exchanger, heating the ammonia, boiling the ammonia, causing the pressure in the heat exchanger to rise. Closed the isolation valve, closed isolation valve and block valve prevented the high pressure ammonia to escape, and pretty much it ruptured the disc and the shell of the heat exchanger. And it injured 6 employees and killing 1 person. So on the right here, you can see the timeline of what the incident happened, how the incident occurred. And the one thing I would like to highlight is on the bottom where you see the incident was declared over at 11 a.m. and the fatality discovered was after, not until 1:20 p.m. And we're going to talk about that a little bit after, but you can also see a picture of the ruptured heat shell and tube heat exchanger with all the debris around. So pretty much the aftermath revealed the opportunities with on-site emergency response training. Goodyear's emergency response planning required a plant-wide evacuation and shelter-in-place drill to be conducted at least 4 times a year. But when OSHA came in and interviewing the employees, revealed that it was not conducted in the last 4 years. So that was a big red flag. For employees, plant alarm systems was highly unreliable and had to use a radio and word of mouth to communicate this sort of incident to evacuate. Due to malfunctioning of the electronic badge system, Goodyear team had to rely on the handwritten list, leading to a miss head count and wrongly conclude the event at 11 a.m. And that's what I just wanted to say. I wanted to highlight that. So it was not until later, 1:20 p.m., and the operations supervisor assessing the damage found the victim buried under the debris. Gaps identified were with maintenance. There are gaps identified with maintenance and operating procedures. There is no lockout tagout violation procedure followed. And there was no following of a good work order process either. The communication gap between the shifts and teams. It was also observed that the Goodyear's maintenance procedures did not address the overpressure situation of ammonia when the relief-like valve was blocked, nor did it require a maintenance staff to be stationed at the vessel to open the isolation valve if the pressure increased above the operating limit. So just to put everything in perception, really, the whole presentation, what it boils down to. I mean, like I said, ammonia refrigeration and the process safety around it, they go hand in hand. If we're going to talk about the ammonia refrigeration, we need to, with equal importance, we need to talk about the process safety around it. So in conclusions, really, the success of the PSM program is identified by safety performance metrics, like we talked about the top 10 leading metrics, regulatory compliance and operational efficiencies, understanding and addressing the needs and contributions of the stakeholders to ensure the success and robustness of the PSM program. And as we all know, the frontline employees, they are heavily and they need to be heavily invested in the PS process safety. As they're the frontline employees, they are exposed to the highest potential of the risks. Involving these employees, the frontline employees, and employees at all levels of the organization in PSM ensures that it is widely understood and supported. That being said, any questions?
So, yeah, thank you so much for that excellent presentation, Kushal. That was full of practical insights and real-world advice. So yeah, we can
Absolutely.
start our QA session. Yeah, we've already got some questions. If you're ready, I can ask you the first one.
Yeah.
So what's the one mistake you see most often during the startup phase of ammonia systems, and how can teams avoid it?
So I think ammonia startup systems depends. I mean, MOCs, I've seen a lot of companies follow the management of change processes, but one thing I've seen commonly that fails is following through the recommendations on the MOCs. So when people about it could be anything around the training or the follow-ups that we document on the MOCs is something I usually see gaps across the industry where we as an industry don't do a good job following through the recommendations on the MOCs. And it could be training or engineering design recommendations, so on and so forth. But that's a pretty common one I've seen because the mindset
Mhm.
is we do an MOC, we make a change, we do the change, and we move on with the change. And then something else takes a priority, and we kind of forget about the recommendations that were or made on the process on the MOC. So something else takes a priority. So with that mindset, we kind of tend to forget about the recommendations we made, and that I've seen as a gap, huge gap, industry wide.
All right. Yeah, thanks a lot. While we're waiting for more questions, I want to remind the audience that, yeah, you can drop your questions. And if you don't have any, please write your impressions, maybe some key takeaways. We would love to hear some feedback from you. So there are two questions from the same person here, so I might just read them together because I think they're connected.
Okay.
So the question is where to get your first training certifications and what certifications are recommended in your opinion?
So, and I'm going to be honest with my personal experience. So when I came as a new individual to the ammonia refrigeration industry, I went through a combination, which is pretty much season following up with the season mechanics or team players, because that's where you get to see the real life experience in the field. But for the formal training, we have been through, and what we follow is a standard approach where we send our folks to official training at the local community college or organizations like RITA. They offer RITA Operate 1, Op 2. Uh, they offer courses like the process safety management and the safety management, which focuses on all the 14 elements of the PSM program. So I think those would be a good starting point where the local community college training sessions or training programs or uh, the organizations like RITA, they offer pretty solid programs to build that foundation.
All right. Yeah, great. Thanks a lot. The next one we've got seems to be a more practical one. So it's quite a big one. I'll read it out. Why you need to have a rupture disc installed when there is already a safety valve? Common practice is that there cannot be a block valve installed in between pressure vessel and the safety valve.
That is correct. So as per the good engineering practice, we are not supposed to have a block valve between a ruptured disc or ISO relief valve. And that's not a good engineering practice. That I definitely agree on being one of the recommendations on or the engineering flaws where it was not designed right by having a globe valve or isolation valve in between.
Mm-hmm. All right, I hope that answers the question. So we have some more if you're still interested to hear them. So what are the
Yes.
best practices system design?
What are the best practices in the system design?
Yeah, it seems so. Yeah, what are the best practices system design? So I'm just reading it. Um, I don't know, maybe. Does that
Okay.
make any sense?
What are the best practices in the system design? I'm just trying to make sense out of this thing, but uh, so I think I don't fully follow the question, but when it comes to uh, okay, I can talk about the safeguards or so IIR 2 has standard design or designing a safe ammonia refrigeration system standard out there. So that's a absolute good document to start, and there's a good, it talks about all the safeties, good engineering practices, best practices in the industry that we need to comply and design our system to keep our ammonia refrigeration system safe and sound. I think that's a good safety point, and I hope that I answered the question. But I think that's a good starting point. That's what we follow uh, ma majorly uh, on the ammonia refrigeration system. But when you talk about the process safety management piece, I think what we talked about having a good process safety management team at the site, and it's not one person job. I think what I'm referring to is it's a team effort. So and the culture does not change over time either. So it takes a constant or consistent stepping towards the right process safety culture. So uh, we need to keep building onto that to work towards a safe process safety environment. But I think so. That's why I wanted to address two different aspects here. One, the ammonia refrigeration side, and one, the process safety. And hope that answers the question there.
Yeah, let's hope so. And we have got a comment following the question up, the one we had, why you need to have a rupture disc installed when there is already a safety valve. The person is saying that they still didn't get an answer why there is a rupture disc. So why specifically should there be one? I guess that maybe that was the question.
Let me go back to that. It could be one thing I can think of is the preliminary or primary safety measure could be the rupture disc and could be a sign of a preliminary failure before it goes to the relief valve. That's one thing I can think of, and reason why we have a rupture disc in place. But it could be a primary measure.
All right. So shall I move on to one more?
Yes, please.
So do you have anything for overfeed ammonia design?
Overfeed ammonia design.
That's what it says in the question, yeah.
Do I have anything for the overfeed ammonia design? I don't follow that question fully.
Maybe the person who asked this question, maybe you could rephrase it, please. Yeah, maybe write it in the chat or in the QA. But we have one more connected to, I guess it's close to the question about certification. So someone is asking, what are the best practices for the ammonia workers if they're a beginner?
Okay. So, like I mentioned before in the presentation, few slides, and really the best practices are shadowing your seasoned mechanics, having a good onboarding program, onboarding plan for your new individuals, and providing them all the tools and resources they need to be successful, rather than just expecting results in the first 90 days or 6 months. It's better to give them all the tools and resources so they can learn, ask questions, and encourage that behavior where they can ask questions and they can absorb more and learn more from the season mechanics, and then pretty much implement the learnings in the 6 months from now. But I think that's the best practice to help them pretty much learn and absorb the work environment.
All right. Yeah, great. Thanks a lot. And I guess we have one more last question, so we'll wrap it up with this one if there won't be any others coming in. So how can you know that the ammonia in the system has been contaminated and how to prevent it from contamination?
Sorry, what was the question?
Yeah, I can repeat that. So how can you know that the ammonia in the system has been contaminated and how to prevent it from contamination?
So one thing I can think of, and it can be many different ways, but I will just talk about oil. Oil in the system, when you start to see when you have to refill or replenish your compressors with the oil, that oil is going somewhere. It's pretty much it's getting sucked up into your system. It's impacting your cooling capacity. That oil is going into your low side system, and pretty much over a period of time, you're going to lose your cooling effectiveness, and that's one way to tell. And of course, your oil draining activities. That's why we have to have a monthly oil draining activity PM through the oil pots. So, but.
All right. Yeah. So yeah, thanks a lot. Thanks a lot to all the participants. And thank you so much, Kushal, for this insightful session. Thanks
Absolutely.
all for joining us. Yeah, recording of this webinar will be emailed to all the registered participants. You can also check it on our YouTube channel a bit later. So please feel free to share it with your colleagues if you know people who will find it insightful. Also, don't forget to connect with Kushal on LinkedIn. There should be a link somewhere in the chat here, so to continue following his work. And finally, we would love some of your feedback. So I'm going to launch the last poll we've got about your impressions. We hope that this webinar was insightful and useful to you. Please write your feedback in the chat as well. And I'm launching our last poll. Thanks a lot for the reactions. I can see them coming in.
Thank you so much, everybody.
Yeah, thanks a lot for your time and your expertise, Kushal.
Absolutely. Anytime.
All right, so I can see some people answering, and I can see people writing in the chat. So thanks a lot for your time, and I guess we can call it a day. So be sure to follow Ref Industry for future events and industry insights. Thank you again, and have a great day.
Thank you.